This is the first video on section 2.7, ratios and proportions. So this section is going to start off talking about ratios, and a ratio is the quotient of two quantities. Also, another way to say it is a way to compare two numbers or quantities. So there's generally three ways you see ratios expressed. You could put it kind of in words, the ratio of A to B. You can write the ratio of A to B with a colon in between the A and the B. Or you could write the ratio of A to B in this fractional form. We'll tend to use this fractional form because after we put a ratio in a fractional form, we can use the rules that we know about fractions to work with it. So A and B are called the terms of the ratio. Ratios are generally written in lowest terms by dividing out any common factors, just like we do with any other kind of fraction that we'd write. So, for example, I've said the ratio of 12 to 15 in lowest terms would be 4 to 5. Just like if I wrote the fraction 12/15, I could reduce that fraction down to the fraction 4/5. So they're equivalent, and this would be the lowest term fraction or the lowest term ratio, 4 to 5. So let's look at some example problems using the idea of a ratio. The first one, it says on exam there were 6 A's, 13 B's, 6 C's, 4 D's, and 1 F. And the first thing it's going to ask us to do is find the ratio of the number of A's to the number of D's. So I'm comparing A's to D's, and we read a ratio top to bottom when we write in a fractional form. So we'd put 6 on the top versus 4 on the bottom, and if we'd reduce that down, we'd get 3 to 2. So there was 3 A's for every 2 D's given. The next one is going to ask us to find the ratio of A's to C's. A's to C's. So if we do that same thing, we have 6 A's compared to 6 C's. So I could write the ratio 6 to 6, which reduces down to 1 to 1. If I was writing it not in fractional form, but this other form, it would look like the ratio of 6 to 6, simplifying to 1 to 1. So that means for every 1 A, there was 1 C given. And the last one I have here says find the ratio of the number of C's to the total number of grades. So there were 6 C's, and the total number of grades, I would have to add up all these numbers. And when I added those all up, I got 30. So I have the ratio of 6 to 30, which reduces down 1 to 5. So it tells me there was 1 C for every 5 grades given in the class. So that's an idea of what we're talking about when we're working with a ratio. We can write it as two things being compared. We read it top to bottom, and we put it in lowest terms. So after we talk about the idea of ratios, we're going to move on and talk about the idea of a proportion. So let me get that out for you. So a proportion is a special type of equation, and it's a statement of equality between two ratios. By the way, our book doesn't make a big distinction between ratios and rates, and I know some people who had, especially Math 94 here, that book makes a big distinction, being that ratios are numbers comparing things that have the same units, and rates have different kinds of units like miles per gallons or feet per second. This book doesn't make a huge distinction, so when we talk about proportion, it could be two equal rates or ratios. So we could write that A is to B as C is to D, and in fractional form that would look like A is to B as C is to D. So it's an equation that has two equal fractions. Now back in sections 2.4 and 2.5, when we went to solve something that had fractions, we often would clear the fractions by multiplying both sides by a common denominator. In this case, the common denominator would be B times D, and I could do the math, multiply both sides by BD, cancel out, and solve the problem that way. So let's go ahead and do that on this problem here. I have x over 4 equals 49 over 28. And I'm trying to solve for an unknown here, this x. So if I multiply both sides of the equation by the least common denominator, in this case 28, which is the LCD, I would be able to solve it. The 28s would cancel on this side. And on here, the 4 and the 28, I have a common factor of 4. I'd end up with 7x equals 49. And then I could divide by 7 and get x equals 7. So one way to solve a proportion is to clear the fractions by multiplying by least common denominator and then solve the resulting equation. There's another really common way, and a lot of people might have used this in the past, and it is called cross multiplication. Cross multiplication says, well, A over B equals C over D. If that is true, then the cross products, which are the numbers you get, the products you get when you multiply, diagonally across the equal sign, are also going to be equal. So A times D is going to equal B times C. Makes that little cross, which is why it's called cross multiplication. So up here, when I started multiplying both sides by the least common denominator, I ended up getting A times D equals B times C. It really just is a byproduct of doing this kind of cancellation. But some people like it because it feels like just kind of a way you can just jump in and get going on these proportion problems. So let's look at that same problem we just did, and we use this cross multiplication method. So we have x over 4 equals 49 over 28. So this method says if I multiply across the equals sign, 4 times 49 is going to equal the product if I multiply it on the diagonal this way, 28 times x. So if I do this multiplication, 4 times 49 is 196 equals 28x, and then I can divide both sides by that 28, that coefficient, to cancel it out and get x equals 7. So I get the same answer. It's just kind of a different, different approach for doing that problem. So this cross multiplication is a really common way to do it. It only applies to this situation where you have a fraction equals a fraction. It's a special kind of equation, a proportion, and it's the only place that you use this idea of cross multiplication. So let's just take one more problem and look at cross multiplication. And we'll take a look at this problem. Solve the proportion for the variable 3 is to 12 as negative 1.4 is to z. So if I do the cross products, cross multiply, I multiply across here, 12 times negative 1.4 equals 3 times z. So I go 12 times negative 1.4. When I multiply that, I get negative 16.8 equals 3z. And then divide by 3. Z equals negative 5.6. Now, some people didn't even learn this kind of algebraic written down way. They just learned multiply and then divide. And that is really what I'm doing. I'm just kind of showing the steps algebraically, how I do that. So that's the end of this video, and the next video we'll work on application problems using proportions.